Hi, it's Chris Esson for a new video that can revolutionize physics. Today we will ask ourselves if Einstein's theory of general relativity is totally accurate. I know, asking such a question is a taboo subject for a physicist. That's good, I'm not a physicist, just a guy trying to understand unexplained phenomena. And that's why I'm interested in physics. In the 19th century, physicists wondered how light could be transmitted in the interstellar space, and considered that space was filled with a substance called ether. Between 1881 and 1887, two American physicists, Michelson and Morley, tried to demonstrate the existence of the ether by measuring the Earth's speed of 30 km per second in its movement around the Sun, added to the solar system travel speed in the galaxy of more than 200 km per second. Unfortunately, despite all their attempts, their measurements never exceeded 7 km per second. Einstein developed a theory compatible with the results obtained by Michelson and Morley. The two founding principles of his theory are: ether does not exist, so the vacuum is really empty. Speed of light, noted c, is constant in all reference frames in translation. If light is placed in front of a spacecraft advancing at speed v, the speed of light beam is c and not v plus c. Einstein released the first version of his theory of relativity in 1905. One of the consequences of the above assumptions is that there is no absolute reference frame because no fixed reference frame is possible. So everything is relative. The law of velocity composition is modified according to the formulas previously found by Dutch physicist Hendrik Lorentz. Assuming we have a first observer on Earth and a second observer in a spacecraft moving at a velocity v, Einstein deduced from this that time, length, and mass vary according to the relative speed of the two observers. A passenger in a craft is supposed to age less quickly than an observer on Earth. But if we say that it is the Earth that is moving away from the craft, we get the opposite result. It's called the twin paradox. We also deduce from this that nothing can go faster than the speed of light, no particles, not even a wave, and by an energy analysis, Einstein arrives at his famous formula, E equals mc squared. It raises a few questions. Why doesn't the speed of light add up to the speed of the craft? How is light transmitted in a vacuum? Why do masses increase with speed? How to explain the twin paradox? In 1915, Einstein released his theory of general relativity, which completed the special relativity for accelerated frames. The fundamental starting point of general relativity is that no distinction can be made between an observer on Earth undergoing gravity of 1g and an observer placed in a craft accelerating to 1g. In the first case, we have weight equals heavy mass times gravity. In the second case, we have weight equals inertial mass times acceleration. Einstein considers that it's impossible to distinguish between these two masses. Heavy mass equals inertial mass, and gravity is indistinguishable from acceleration. Einstein comes to the conclusion that matter curves space, and he extends his principle to all forms of energy, according to the principle of matter-energy equivalence of the formula E equals mc squared. General relativity has led to a number of predictions that have proven to be accurate. Calculation of the advance of Mercury's perihelion. Deflection of light rays in a gravity field, with a value found twice as high as a result of the Newtonian physics. Existence of gravitational lenses, consequences of the previous point. Gravitational shift of light waves frequencies. Even if Einstein arrives at accurate results, or at least verified experimentally, with very good accuracy, are his assumptions the right ones? Cosmology faces today several major problems. Hubble discovered in 1929 that the universe is expanding, and, according to general relativity, all the energy in the universe creates a gravitational pull force, so this expansion must slow down. Unfortunately, it was detected in 1998 and confirmed in 2013 that the expansion of the universe is accelerating, which is incompatible with the theory of general relativity, and physicists were forced to introduce a new concept, dark energy. Another mystery not explained by cosmology is the speed of stars on the periphery of spiral galaxies, which does not decrease as expected by the theory of relativity, and which is at the origin of the introduction of dark matter to explain such a mystery. This chart shows us that 96% of the universe's energy cannot be explained by current science. Finally, it's impossible to unify quantum physics, general relativity, and electromagnetism. In short, we are going to try to put all this in order. Let's have a look to the Wikipedia page indicating the achievements of general relativity. Let's begin by analyzing the calculation of the advance of Mercury's perihelion. This result is obtained by using the so-called Churchill metric, the solution of Einstein's equation, in the case of an isolated spherical mass without rotation. Rs is called the Churchill's radius of a star, here the Sun, equal to 2 large G large M over c squared. And we then have the following equation. In a flat universe without gravity, the equation stands as follows. In the first equation, we can state c prime squared equals c squared times 1 minus Rs over R. So c equals c prime over square root of 1 minus Rs over R, which means that the gravity field introduces a refraction index n, which applies to the time coordinate c times t. With regard to the deviation of light rays in a gravity field, the general relativity obtains an experimentally correct value, twice as high as a calculation in Newtonian physics. Indeed, Newtonian physics takes into account the deviation of photons according to their energetic mass, h nu over c squared, and results in the deviation of an angle of 2gm over c squared r. We have here a very simplified and not really rigorous demonstration that leads to the right result. As early as 1911, Einstein understood that gravitation influences the speed of light and can deflect light rays by a refraction effect, like in a lens. He shows here that this effect is responsible for a deviation also equal to 2gm over c squared r. However, he forgets here to take into account the deviation obtained in Newtonian physics to obtain the correct total result of 4gm over c squared r. The existence of gravitational lenses is only a consequence of the previous point. The gravitational shift of light wave frequencies is a calculation that takes into account the variation of potential energy in a gravity field, which is added to the energy h nu intrinsic to a photon. This demonstration uses only the mass energy equivalence of special relativity and is therefore independent of general relativity. So, if I summarize, the validity proof specific to the general relativity, namely the advance of Mercury's perihelion and the correct calculation of the deviation of light in a gravity field, are in fact the consequence of the variation of the refractive index of the vacuum by a ratio equal to 1 over square root of 1 minus Rs over R. Let's see if we can find such a result with another approach. In Newtonian physics, it is said that gravitation derives from a gravitational potential equal to minus gm over R, but nothing really explains what creates this gravitational potential. We then obtain the two classical formulas giving the value of potential energy and gravitation. We will unify the notion of gravitational potential and the notion of vacuum energy, and everything will become much clearer. In the previous series of 3 videos entitled From Maxwell's Equations to Nikola Tesla's Theory of Gravity, we discovered the relationship G equals minus K grad P, where K is a unit conversion constant and P is the pressure of the vacuum. I remind you that pressure and energy density are equivalent, because Newton per meter squared equals Joule per meter cube. Dimensional analysis led us to the relationship G equals minus C squared over P0 grad P, But we are going to refine it a little bit. P0 represents the pressure of ether away from any mass. C represents the speed of light. We might as well have written G equals minus K times C squared over P0 grad P, where K is a dimensionless constant, because there is no evidence that K equals 1. As seen in the previous video, we then obtain divergence G equals minus K C squared over P0 times Laplacian of P. But we also know that divergence G equals minus 4 pi rho m G. Rho m is the volumic density. We then obtain this relation. By taking K equals 1 over 2, we obtain then Laplacian of P equals lambda rho m C squared. Lambda is Einstein's cosmological constant. We deduce that matter absorbs ether in proportion of its volumic density, thus creating a depression of ether. If we go back to the term C squared over P0, which is assumed to be constant, as in a perfect gas, it means that at every point we have a speed of light C prime, which varies according to the local pressure P. We have then C squared over P0 equals C prime squared over P. We therefore need to calculate the pressure P at any point in space in the vicinity of a star mass m. At a distance r from a star of mass large M, of radius large r, we have this relationship. By simply continuing the calculations, we then obtain. It is found that at a distance r from a star of mass large M, the vacuum has a refraction index n equal to 1 over square root of 1 minus rs over r. What is extraordinary is that this result is the same as the one given by the Schwarzschild metric seen just before. Let's now analyze what our approach of ether can give us about black holes. A star becomes a black hole when its radius r is less than or equal to the Schwarzschild radius rs. The previous formula, pressure at radius r equals P0 times 1 minus rs over r, shows us that for a black hole with a radius r equals rs, the pressure is zero on its surface. From a physical point of view, this does not mean much, because the ether constitutes space, and zero ether pressure means that we have no space. I now put you a slide that gives a calculation of the ether pressure inside the black hole, and which leads us to find that in the center of a black hole of radius rs, the ether pressure is minus P0 over 2, with P0 the ether pressure to infinity. It's difficult to imagine negative pressure, except by recovering energy from a neighboring universe, communicating through the black hole. The internal pressure formula can be used to find out from which critical radius the pressure becomes zero at the center. Let's say P at 0 equals 0. It's very easy to find R equals 3 over 2 Rs. We can therefore wonder if it is reasonable to imagine stars with a radius less than 1.5 times their Schwarzschild radius, and therefore if black holes do really exist. Let's go back to the very definition of a black hole. For any star, there is a liberation velocity that allows you to escape the attraction of the star. For the Earth, it's 11 km per second, and is calculated with this formula. VL equals square root of 2jm over r equals c square root of rs over r. It's easy to see that when the radius is less than the radius rs, then the liberation velocity exceeds c. The light can no longer escape from it, hence the expression black hole. But it should not be forgotten that the speed of light is slowed down in the gravity field according to this formula, valid outside the star. So, for a black hole, it's necessary to take into account the slowing down of the speed of light to find the true horizon where the liberation velocity is equal to the local speed of light. Assuming as a condition that local light speed equals liberation velocity, we find that R equals 2Rs. Contrary to what is commonly accepted, a black hole is obtained as soon as the radius of the star is less than or equal to 2Rs. This suggests that a black hole may indeed exist without spatial or temporal discontinuity, nor may it require communication with another universe, provided that its radius is between 3/2Rs and 2Rs. To conclude, if we take again the basis of Einstein's general relativity, space is empty, and the notion of ether is useless. All forms of energy curve space-time. There is no absolute reference frame. The speed of light is constant in all reference frames in translation. All this seems totally wrong, but this has not prevented cosmology from achieving accurate results, at least until it is discovered that the universe is expanded at an accelerated rate. As Einstein predicted in the letter of 1925, if the presence of ether is demonstrated, then from the theory of general relativity, only the principle of equivalence will be retained, which is very well explained thanks to the presence of ether. Indeed, an observer on Earth sees an ether flow with an acceleration of 1g directed towards the center of Earth, while an observer in a craft accelerated to 1g crosses an ether flow that seems to be accelerated to 1g. The ether really exists, as Tesla said, and serves as an absolute reference, at least in areas far from any matter. Matter absorbs the ether in proportion to its density, and gravity corresponds to the depression of the ether flow. The so-called gravitational waves are compression waves of ether, like the sound waves in the air. The speed of light is a limit speed depending on the ether pressure. Spiral galaxies can be likened to gigantic ether vortices containing plenty of other vortices creating stars. Well, that's it for today. In about 15 minutes, we have just demonstrated the limits of general relativity and proved that gravitation can be explained more simply by assuming that space is filled with ether, as Nikola Tesla has been saying since the 1890s. With this theory, it's possible to unify quantum mechanics, electromagnetism, and gravitation, opening wide the doors of a new physics. But it also raises new questions. Is the Big Bang theory correct? Can we capture the energy of the ether? Is it possible to go faster than light? I'll let you think about it and look for answers to these questions in the other videos of my channel. See you soon, bye bye!